Hi, this is question 9 of the Leave Cert Ordinary Level Paper 1 in 2021. As always, if you want to copy these notes, send me an email to shanetroy@gmail.com. And if you like these videos, just hit subscribe to get access to more playlists. So question 9 here is a sequences and series question. Again, this is a second one in this actual paper, which is unusual. Part A says the first 3 patterns in a sequence of patterns containing dots and crosses are shown below. So pattern 1 is 1 dot, 1x. Then pattern 2 is 2 dots, 4 x's. And this last one here has 3 dots and 9 x's. Okay. So look, even before we look at the question, it's worth figuring out the pattern. Now there's 1 of them, 2, and 3. So look, the next one's probably going to have 4, if the pattern's right. This is 1, and then 4, and then 5. So, sorry, 9. Okay. So it's going up 1, 4, 9. Would the next be 16? I think. Now, effectively, I've seen a pattern here. 1 squared is 1, 2 squared is 4. Now, 2 squared means 2 by 2. 3 squared is 3 by 3 is 9. 4 squared is 4 by 4 is 16. So if there's a fifth one, it'll be 5 by 5, which is 25. 5 squared. So I think that's the pattern. The part 1 says draw the 4 pattern in the sequence below. So look, you have your 4 dots, okay, and you have your 16 x's, okay. Look, I'm not even going to bother filling it in, but just fill in the rest of them. That's that. Now, part 2 says find a formula in n, okay, for the number of dots in a pattern n of the sequence, and they give a hint, t of n, okay. Now, we looked at it in a different video, but no harm doing this again. It's going to bring up a copy of the maths tables, okay, so just to show you that they're a digital version. And if you want a copy of these, send me an email at shanetroy@gmail.com and I'll fire them off to you. So in the contents page, we have the section there of sequences and series. Click on that. I have it highlighted there. I'm going to highlight it again if I can. There, it's that formula, okay. The number of an arithmetic sequence. Okay, now the S of n is the sum of all the values in a sequence. And that's that, okay. So that formula was Tn is equal to A plus n minus 1 times D. Okay, and we know with the number of dots, this is the top pattern. The A value is 1, that's the first value. The difference, okay, goes up by 1 each time. Now we're looking to find a formula for that. That's T of n is equal to 1 plus, now n minus 1 times 1. You can work that out, it'll simplify to 1 plus n minus 1, which works out 1 minus 1 is gone, so you're left with n. Okay, so just for clarity, T of n is equal to n. Let's test it. Is T of 4 equal to 4? It is. T of 5 is equal to 5, etc., etc. Now in the notes, okay, I have the pattern there, and I have the formula and the first in the sequence, the common difference, put them in and then manipulate it down using algebra. Now part A, part 3 and 4, it says find the total number of dots in the first 20 patterns of the sequence. So this is your sum of a series is equal to n over 2 times 2a plus n minus 1 times d. And close brackets. Now just to point out, I got these again from the math tables, and this is the sum of an arithmetic sequence. And that's the second formula there. So in this case, we're looking for S20, the sum of the 20 terms added together. So n is 20, so you can fill in that. Now we know from the first thing that a is 1 and d is 1. So just fill in the unknowns. So 1 for a, plus now 20 for n, and then 1 for the d. That can go to the calculator, okay, or do by hand. 20 divided by 2 is 10. Do inside the brackets, so you can do 2 times 1 is 2. plus 20 minus 1 is 19 times the 1 here. If you simplify that down, it's 10 times, now that's 2 plus 19 times 1, which is the same thing as 2 plus 19, which is 21. 10 times 21 is 210. So the sum of the first 20 terms is 210, which in essence is, it was 1 plus 2 plus 3 plus 4, etc. Okay, and that's that. Okay, now in part 4, it says the table shows the number of crosses for the first 2 patterns. Complete the table and hence find a formula for the number of crosses in pattern n of the sequence. So 1 gives 1, 2 gives 4, 3 gives, we said if we flick back, 3 gave 9, okay. 4 gave 16, and we identified that as part 1 here. Now 5 would give 25, and 6 would give 36. The number of crosses in pattern n, okay, so if we call n the pattern, well, then the number of crosses is n squared. We kind of mentioned that these are all the squares of the patterns, of the number of dots. So our number of crosses in pattern n is n squared. If I said n is equal to 10, okay, that's the number of crosses is n squared, which is 10 by 10, which is 100. And that's it. Okay, I could check what, actually I probably should check the one I have. If n is 2, okay, well then n squared is 2 by 2, which is 4, which is what we got in the table. And we were given that information. So my pattern works, and that's part 4. Now in the notes, I have that formula, I have the information I have, sub it in, put it to the calculator, got the 210. On the second one, I just filled in, I kept that pattern going, and I filled it in, and I managed to identify what the general form of that pattern equation was. Now, part 5 says, find the number of crosses in pattern 12 of the sequence. Now, if the number of crosses, okay, is given by n squared, well then pattern 12, okay, is 12 squared, which means 12 times 12, which is 144. Now, part 6, find the number of shapes, dots and crosses in pattern 10. So dots is one thing, crosses is whatever. So pattern 10, okay, should have 10 dots, okay, and crosses, it should have 10 squared is 100 crosses. So that's fairly handy, okay. That's, if I'm not mistaken, 110 shapes, okay, 10 dots and 100 crosses. Now it's worth pointing out here again, and I may have mentioned this already in the question. If you had gone wrong back here, okay, with this one here, that would affect your answer in part 6 and part 5, okay? Now, it wouldn't, if you had, no matter what you declared in the previous answer, okay, let's say you thought that was 2n or something, it would be accepted as correct in the future parts, even though it was wrong in part 4. If you would use that wrong value from part 5 and 6, you'd still get the full marks. Now, that's just the notes done out, hopefully in an understandable way. So part B here has a different pattern. It says the first 2 patterns in a sequence of patterns of crosses are shown below. So you've 1 cross in the first pattern, 2 in the second. There seems to be a difference of 2, so there might be 5 in the next, but I'm not 100% sure. It says the number of crosses in pattern n is Tn. So that's just bog standard, okay? So T of 1 is equal to 1, T of 2 is equal to 3, T of 3 is equal to whatever. The general term describing T of n can be written in this form. So this is telling you what happens each time. This is the pattern, okay? Now it doesn't look like it's going to go up by 2, but I'm not sure exactly what's happening. It's confusing enough. There's 1 unknown, 2, now that occurs twice, 3 unknowns, 4 unknowns. So not sure what's going to happen here. It's been a while since I've done this question. So part 1 here says use substitution for n to write T of 1 and T of 2 in terms of B, C, and a number. So T of 1, so we know in this case that and this actually T of 1 and T of 2 were given in the exam paper. So T of 1 is equal to, well, 1 squared over 2. I'm just replacing the n here by 1 plus, now the b, I don't know what that is, but I know the n there is 1 again, plus c. Now that can become 1 squared is 1, and 2 stays the same, so it becomes a half plus b times 1 is b, and then plus c. So that's T1 in terms of b, c, and a number. Now T of 2, so that's n is equal to 2, is equal to, again, using this thing up top here, okay, so n is 2, so you get 2 squared over 2 plus b times 2 plus c. So again, for the n in both places, I've substituted the 2 because it's the second in the pattern. Now that becomes 2 squared is 4. That becomes 4 over 2 plus b times 2 is 2b plus c. Now that becomes 4 over 2 is the same thing as 2 plus 2b plus c. And that's in b, c, and a number. Now it says part 2 here, hence or otherwise, find the value of b and the value of c. Now this is in the case of T1. I knew that T1 is equal to 3. I also know that T1 is equal to a half plus b plus c. Now if you copy, and this happens a lot in maths, those two things are equal, therefore these two things are equal. And I can make that statement. Okay. Now, once I've got that, I've got an equation. I can solve this equation. Okay. Well, not solve it, sorry, I can't solve it, it's two unknowns. But I can rearrange it or simplify it. If I bring the half across there, it becomes 3 take away a half is equal to, actually I'm wrong there. I've just realized that's not a half. T of 1 is not equal to 3. My apologies. Let's clear that away. T of 1 is equal to 1. Okay. The first pattern is 1 cross. So that's 1 is equal to a half. Okay. So I'm just fixed it here. Apologies. I don't know what my brain was not thinking. Now that becomes 1 minus half is a half is equal to b plus c. Now the same thing for T2. So T2 is equal to 3, but T2 is also equal to 2 plus 2b plus c. That's what we identified in the previous part. If these two things are equal, then so are these two things. And I can create the statement 3 is equal to 2 plus 2b plus c. Now, to solve this, you can not solve, sorry, to again rearrange or simplify, bring the 2 across. 3 minus 2 is 1 is equal to 2b plus c. Now, I now have two equations of two unknowns. So I have this equation of two unknowns and this equation of two unknowns. And that's simultaneous equations. And they've actually assessed that twice already in this exam. It's weird. That's 3 times in the whole exam paper, and there's still a question to go. So it's kind of odd. Now I'm going to bring us to the answer in the notes. Basically, what I did was I have the two values. That's the ones identified in the previous page, the two different equations of two different unknowns. I'm using here the substitution method. Okay, I could use the elimination method, but in the notes here I've chosen to use the substitution method, where I take one of the equations. Now you always take the one that's easiest, and I rearrange it for one of the unknowns. So in this case, I've moved the 2b across the far side. I end up with c equals 1 take away 2b. Now, c is this. This and c are the same thing. Now, in the second equation, so this equation here, instead of c, if you can see what I'm doing here, I put in 1 minus 2b. If I look now, okay, that's an equation of one unknown. Now, the unknown appears twice, but it's the same unknown. So this is solvable. It's just a matter of going ahead and doing it. Now, first I do there is remove the brackets, but I can do that by just multiplying the plus in, which incurs no change. So b plus 1 minus 2b. Now the b's can combine, okay, and I end up with, I've done a few things here. Let me do it up here. B plus 1 minus 2b is equal to a half. Now, I've combined b and minus 2b is minus b. Okay, plus 1 is equal to half. Now I can bring the 1 across. It's added on this side, comes subtracted over here. That creates a sum. A half take away 1 is the same thing as minus a half. And then I go, well, I can swap them, or I can go multiply across by a -1. Minus by minus changes that to a plus b. Minus by minus changes that to a half. So I found that b is equal to a half. That's what I've shown here in the notes. Then I can use that value in either equation, but I already have an equation rearranged for c, and I'm looking for c, so I'm using that one. Instead of b, I put the half, which I just identified in my previous work. I put 1 minus 2 times a half. That's the same thing as 1 minus 2, 1 minus 1, which is 0. So my b value is a half, my c value is 0. Now, I should probably have a slightly more obvious in terms of what I'm doing here, but there's kind of not much space. And as I said, that simultaneous equation is asked 3 times, which is amazing from one perspective. Okay, so this is question 9 of the Leave Cert Ordinary Level Paper 1 in 2021. As always, you want to copy the notes, send me an email at shanetroy@gmail.com. If you like these videos, hit subscribe. Thanks.